Hi, hello everyone. Second podcast. Welcome once again, Dr. Shankar. I'll give a short introduction. He has more than a decade of experience, industrial experience. So he has a doctorate in control systems, and then he achieved gold medal in Anna University in control systems. Yes, this topic we are going to discuss about where and all control system is used. What is control system? We will discuss in depth in control systems with Shankar. I heartily welcome you for the second podcast.
Yeah, thank you, Gautam. So, as you mentioned all about what I am and who I am and what I'm doing and all those things, but yeah, and I will just come cut to the chase. I will come. What is control systems? So control systems is basically like kind of an entity
Mhm.
which will help you to regulate what you want to achieve in an automated way, to
Okay.
in a plain English to say.
Okay.
So that will monitor,
Mhm.
that will help you to regulate what target you want to achieve,
Mhm.
and so that and also you can able to modify it in such a way that it should that how it is achieving the target also you can modify it, whether it is can go fast, you should achieve in a slow manner, or consumption of energy should be less. All those things are all matters, so those things are all being taken care in an automated way. That's what control systems is
Okay.
in a
Mhm.
nutshell, I would say.
Okay. Great. Great. So Shankar, from my point of view, control system in engineering itself, it is very toughest subject in engineering history. I can say, like whoever sees control system, like they will get scared of it. Okay, but now what things you jump into control system, like you did masters in control systems, then you you achieved great things in your PG, and then followed by that, like you did many research, and you has many research journals in control systems, and then currently you are working in control systems, like somehow control system and you are you and control systems are linked together, like okay.
So basically speaking, it's a kind of a stereotypical thought that control systems is toughest subject. Truth to say is the was one among a few subjects where you don't want to read for final exams. Control systems. If you understand the concept, it's like kind of straightforward from there. You don't want to read at all. You just want to just go apply that and come back. But what happens is, it's like I would say the gap in academic is, and there is no proper way of teaching it, I would say. Just what is in the book they will teach, and for me it happened. Maybe like kind of if they say some applications for it, and where it can be used and how it is being used in industry, like the teacher has to have that exposure also. So that's why I have always say something like kind of a very important subjects you should have some experienced teachers from industries, which
True.
who will know, or you should have a link between industry and academics. So
Okay.
that disconnect only makes this control system as toughest subject. For
Yeah.
me, for me, where I got interested in control system is when I was going to gate coaching,
Mhm.
like for preparing for masters. At that point, I studied about control system. The way they thought about control systems all were different. They were like not like kind of a direct way or something. They said this is for this purpose they have, and this is for that purpose they have. And NPTEL videos I am seeing, it's lot differ what I was studying in college,
Okay.
where my
Okay.
teacher was teaching me.
Okay.
So then I
It's
got
not a
interested
bookish
in
way you are telling. So it's not a bookish way, like more a practical way of explanation.
practical
Uh,
way. All were taught in practical way. And one more thing is, control system cannot be like kind of made as a bookish subject. I would say there is no
uh,
theory at all. Even
okay.
if there is no 5% theory, or maybe 5%, 95% is application.
Yes.
So
Yes.
that point only thing. And next, when I entered my masters, the teacher there inspired me, the professor. I
Okay.
think so now she is retired,
Okay.
but without her, it would be like kind of, it would be a very tough thing for me. But
Okay.
that gave me an inspiration, I would say.
Okay. 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 Thanks, Shankaran, and like for your love on control systems, I can say. Okay. So now we'll jump into technical part. Yeah, Shankar. So can you tell me, we have microcontroller and microprocessor. So in last discussion, we were discussing about MATLAB modeling and everything. So where this control system come into picture? Like that code itself, you are telling the control system part, or like where it is? Can you explain that?
No, it's like kind of a law, mathematics behind it. It's a pen and paper work. We will do
Okay.
all the pen and paper work and we will put the settings there.
Uh-huh.
And that settings, that pen and paper work is also a control system development. So I would say it's not only bounded for code, it includes coding also.
Mhm.
But it is apart from that, it is a very huge scope. You
Okay.
have to analyze the system, you have to find the operating point of the system. From there, you have to derive the settings of the system, how to control and where to control. And all those things are all, this compromises control systems. Sorry, this comprises control systems, I would say.
Okay.
It's not like a microcontroller. For the final
Then
settings, you will put it in a controller, which is microcontroller, that's coding. That also is there as a part of your this thing.
then you are telling the core logic is the control system. So whatever you do that logic in pen and paper, or you use some MATLAB like tools or some other tools, you just derive it, then you change it into code, then flash.
Hmm.
So
Yes.
okay, so then the major part of the control system, it's come under application of our system. So, for example,
Hmm.
consider a missile system. Okay,
Hmm.
so missile system has many things like projectile target fixing, then location tracking, whatever you name it. So we have to as you told, comprise of all the environmental things. Then our core logic will work. So my so whatever I'm telling, that's correct.
Yes, yes, exactly. That's the thing.
Okay, okay, fine. Now, when I was studying control systems, so many there those things are jargons for me. Okay, so Nyquist plot, poles and zeros. Oh my God, transfer function. Okay,
Hmm.
really, I hate everything literally. Now, can you tell me? Okay. So now can you tell me like as you know, like I know transfer function, like you do some modeling and all. What is this Nyquist plot? What is poles, zeros? Like I want a layman perspective. Okay, so
Okay.
like how these things work? Like where can you give one example like where you will use all these things?
Yeah, I can give. But before that, what you said, I am getting a thought process, like an epiphany. Like I heard this story from somebody. Like there was in battalion of the Indian Army, there was a particular chair.
Mhm.
It's like kind of a, like what to say, like it's a chair which is armchair which is present on the park.
Uh-huh.
So it's a resting chair, and always bodyguard would be like standing there.
Mhm, mhm.
Two armed persons will be bodyguarding this chair.
Uh-huh.
And everybody didn't question it, what it is this thing. And finally, one person questioned it to a old, and he went through the process, how much time it took. So they have been doing this for many years. Then he went to a person who has been from that time and he asked, why this chair has been guarded by people? That person replied like, oh, still now the paint of the chair is not dried up. So it's like kind of nobody knows why it is happening. They just continue the process as it is. Just you should not change the process or something. It should be like kind of what to say, tradition there like that. So the thing, transfer functions, poles and zeros are all thought in terms of like just as, okay, this is pole, denominator is pole, numerator is zero.
Mhm.
And where you don't know what is transfer function. Transfer function is some transfer function. Why it is called as transfer function? Nobody says. That's the reason it's we have this gap to say. If they would have explained what is transfer functions and all those things, that would be a good thing. So I will take two terms. I can't explain all the things, but I can give you two terms. I will explain about what is transfer function and what is poles and zeros here
Mhm.
in layman terms. From the name transfer functions, can you say me like what it means? In a layman term, you tell me what it mean by transfer function.
Something it the function which transfer from one form to another.
You got
Okay.
the point. That's what it
Okay.
plainly named.
Okay.
So it converts your time domain signals into a frequency domain signals. That's the only thing.
Oh.
This function, if you pass an input to this function, let us say it is a sinusoidal wave.
Mm-hmm. Mm-hmm.
Sinusoidal wave with respect to time, how you will say at the time t is equal to zero, the output, the thing will be zero.
Mm-hmm.
And if you give based on frequency, like say 1 hertz or something, then at 1 second, your full cycle will be over. Then 0.25 second, you will reach the positive peak. Point for 0.5, you will again go to zero. That's a sine wave, right? You have a upper lobe and lower lobe.
True.
So it's a time-based thing. So I can define that signal in time points. But this transfer function will convert that into a frequency domain where it will be converting it into amplitude and frequency. That's it. It will never, it will just mask the time parts itself from there.
Okay.
You may ask why you want to convert these things from time to frequency and all those things.
Yes, I about to
The
ask.
first thing, yeah, first thing is like kind of make it easy.
Okay.
So you have differential equations, integral equations, which tells about dynamics of your system. However, the system can be defined as by dynamic equations, or ordinary differential equations or something that will say how a rate of change of, like for example, how a car moves. The rate of change of position is velocity. The rate of change of velocity is acceleration. So these are all derivatives, right? One derived from other. It's a derivative.
Yes. Yes.
If in case like say like it's a huge power plant, you have like 10th derivative or 11th derivatives equation to solve it. My method, it's very tough. Here those things are all converted in frequency domain is that derivative will be converted as multiplication,
Okay.
and all your integrations are converted into division.
Mm-hmm. Mm-hmm.
So in such cases, which is easy to handle, division and multiplication?
True. A simple mathematical thing.
Yeah, that's one thing. Next thing is in for example, if you take a valve, or you take a human body. I'm eating now, I am digesting my food, I am absorbing all the nutrients. Eating my food is my input, absorbing all the nutrients is my outcome.
Mm-hmm.
Okay, so it takes 4 hours for me to digest the food and absorb its nutrients. Correct? So that's a frequency my body can accept.
Mm-hmm.
If I'm going to ingest food every 2 hours, there is a lag happens. It can't process that fast. So then what happens there? You will not have a proper assimilation of your nutrients there. It will just throw out whatever it is, like can't be absorbed. So those things are all waste of energy, right? Waste of energy. You're not absorbing any energy from it.
Yes.
So
Yes.
those things are all like, instead of having each testing like 2 hours once I'm giving food, 1 hour once I'm testing the system, 2 hours once I'm testing the system, 4 hours once testing the system, how it behaves, whether it is assimilating it or just throwing it away. That is time domain. You have to create new signals for it and give and see, observe. But in frequency domain, it's less broad spectrum. You can visualize it as a broad spectrum. You can see how your system reacts as you increase the frequency of the mean. It will say in terms of, okay, I can assimilate this way, and slowly it start to deteriorate. That means you can't assimilate. It will be like not processing that inputs. So that way you can observe in frequency domain compared to time domain. So those are all way that this transfer function plays you a major role to ease out your computation, to visualize also. So that's what where transfer function plays a picture. So this nobody says. This
Okay.
nobody says. Okay, these
True.
are all
True.
conventional way. Next thing is poles and zeros. I will just finish it fast.
Yeah.
What do you mean by zero? I will come to zero. I will then go to pole. What is zero? Zero means plainly what?
Zero.
Nothing.
Nothing. Yeah.
Nothing. So if zeros means if I'm exciting my system, or I'm giving an input to a system in such a way that it will not respond at all, that means zero. Poles are nothing but explains how the system behaves. The 4 hours I said, right, for a
Yeah.
system to digest. That 4 hours will be is the pole
Mhm.
that are defined by poles. That's a time constant. To give a practical example, I would say how poles and zeros work out. First, I will say for zero. Zeros, plainly you remember, it's a connections between the strength of input and output of a system.
Mhm.
I have a tank where boiling water happens, and there are bubbles are forming on the top of the tank.
Mhm. Mhm.
Now there is a level sensor which is measuring the level of the tank, how much is the height of the tank, water height is there. It will consider that bubbles also as an level and it will measure it.
True.
Now I'm saying I'm pouring up 1 cup cold water to it. What happens? Your bubbles will burst first.
Yes.
Okay, but level should be like kind of increase, right? As you pour the water, the level should increase, but you will see a small dip in the level because bubbles are bursting. The level will decrease now because the bubbles are bursting. The level sensor will see, okay, now the bubbles are burst. Only it measures. Now there will be dip. Then slowly it starts to increase. So
Mhm.
you see how the interactions of input to the system it affects the outcome of the system it affects. That strength are all defined by zeros.
Oh, okay.
So this
Okay.
is a it will say how for this input how your system interacts. That strength
Mhm.
thing. So you have a slow dip and then it is taken over by a long steady state things. So those things are all zeros will explain. Poles is like if I'm heating a water tank, I'm giving heating input for this much amount of heating input, what time it will take to reach that particular temperature. That assimilation, those things are all defined by your poles. So this way nobody teaches the strength of this inputs and outputs this thing. So that's the reason you may not have. All the things in control systems are done not for no reason.
Mhm. Mhm.
There are some reasons behind it and strong reason behind it, and people accepted those reasons. Then only it came as a part of your
True.
subject.
These explanations is a really layman perspective. I can say like I understood properly what is zeros and poles and everything. Yeah. Uh, Now the my next question, like if I want to start career in control systems, where I have to touch? Like you think you don't say you completed your PG and UG or whatever it is. So think I'm just um, a working professional. I want to model something. I'm into an algorithm development or something. Okay. So people are nowadays, yes, we have AIs, we have lot more tools and everything. But to understand the basic, where I have to touch, what I have to learn, I have to go through
Mm.
all the mathematical things, or I have to buy tons of control system books, and I have to go through like man, like what's the basic I can say?
So I would say one thing is you have to not learn all the things. The
Mhm.
basics such as what is a system, what is feedback, and what can be like kind of stability means,
Mhm.
and what are all the settings for like in conventional industry, in conventional controllers are like PID, proportional integral and derivative. You should know if you change one, what happens to the next.
Mhm.
What will be changed if I'm changing proportional value, integral value, derivative value, how it affects, how the stabilities are related. So that oriented thing. So you start from there, you build around there.
So you
That's a
are
mathematics.
telling about PI, PID,
Yes,
right?
yes, you can start from there. Yeah, learn about system, how it works. Then you can know how to control it. So with the parameters, you can able to say how it works. And advanced level controller requires little bit of knowledge. You have to just sit and start to read on it, and you have to work little bit for it. But with proper guidance, with some kind of, you can ask the help of certain people, or you can search courses which is apt for it. So
Okay.
that would give you like cut short all the books and wasting the times. That would be the best options, I would say.
Okay, great,
Like a
great.
professional who doesn't know
Then
about
you are
it and
telling
he
like
can.
if we kind of if we go through these proportional integral and derivative controllers or PID controller, like we'll have a fair enough knowledge like how the control algorithm works, like where we have to implement these. Like as you mentioned, like I never
Yes.
thought about this bubble in the level. Okay, it's a real time scenario. We should not think always think the tank should always contain water. No, it may contain oil or gas, whatever liquid form. Maybe we can. It may contain beer also. Okay, so obviously a froth will come. So yeah, obviously all the controls are involved. One thing you mentioned here, advanced controls. Uh, Once I heard this name, one name came into my strike into my mind. That fellow Kalman filter. So really, I don't know about Kalman filter, but whoever working in control system, all these algorithms, like they hit on this Kalman filter. What it is, man? Who is Kalman? What it is?
So, give a brief of his name is Rudolf Kalman. So the Kalman filter is being like developed by Rudolf Kalman, and he just used this simple approach of probability and all those things.
Mhm.
So he told that if I have some measurements with me, and some other measurements, some other things are unobserved, like unmeasurable things, and those things are also like maybe distorted by noises. You have some noisy measurements and all those things. It's not a very good one, and it's random. You can't say from where it comes on what is the power of it. If you can able to characterize with some level like this much amount of noise power is there or something, you can get the best probabilistic estimate with some mathematical model I have about it,
Okay.
combining the model outcomes and measurements in such a way that I can have a best probabilistic outcomes of it. So that's what he devised. So it's like kind of I have something in my hand, how I can take a better out of it. That's what. To plainly say, I have two sensors measuring a person like in a particular positions from different angles.
Uh-huh.
So it may give this perspective and this may give in another perspective.
Hmm.
And each one may have its own. You saw GPS may have its own perimeter of
True.
discrepancies, like kind of variability it may have. So combining these two will be overlapping at some point, right? That overlap will be having less variance compared to each individual sensors,
Ah.
GPS sensor. That's the only thing. It's about averaging these two.
Uh,
Whenever there is an overlap happens between these two sensors, that overlap would be very better. Yeah,
ah.
that's what
Then
comes into play.
yeah, then in automotive we use many sensors like this sensor fusion. One thing is there. So there, they'll use this control Kalman
It
filter algorithm, right?
helps hugely, hugely.
Ah, okay, okay. Great, great, great.
So it's average, simple.
Okay, yeah. Great, Shankar. Like, yeah. So we are in the end of today's podcast. So yeah, today I just want to summarize shortly. Yeah, we had a detailed discussion on what is control system, what is zeros, Y transfer functions, zeros and poles, PPAD, uh, like PPAD, like we have to go. Maybe we have
We will take it's a huge thing.
yes, yeah, we'll have again maybe in-depth discussion we'll do. Yeah, then we finally end up with the Kalman filter. Yes, so thanks a lot, Shankar Narayan, for your precious time. So thanks everyone for learning control system together. Yes, happy learning. We'll see in next interesting podcast. Bye bye.